This is Unit 3A review, solve the slope. So from 2 to 17 we're going up 15, from 3 to 3, 0. Anytime we divide by 0, that's undefined. From 12 to 12 we're going change is 0, from 2 to 4 that's 2. 0 divided by anything is 0. Notice undefined slope has the same x values. 0 slope has the same y values. Oops. From 0 to 3 is 3. From negative 8 to 4 is up 12. 3 twelfths can simplify to 1/4. From 3 to negative 9, that's going down 12. From negative 5 to 2 is going up 7. From 8 to negative 12, that's going down 20. From 3 to 1 is going down 4, so that's 5, or 5 over 1. Negative 2 to 7 is up 9. Negative 6 to negative 3 is up 3. 9 divided by 3 is 3, or 3 over 1. Identify the slope and y-intercept of each graph. So our y-intercept is 2. Our slope looks like we're going up 1 over 1. So that's y equals 1x. We don't need the 1, plus 2. Here our y-intercept looks like it's at negative 2. And our slope also looks like it's negative. We're going down 1, 2 over 1, down 2 over 1, or just negative 2. So y equals negative 2x minus 2. 9, a community pool is being drained for cleaning at 9 a.m. The pool is 23 feet deep. At 1 p.m. the pool is 15 feet deep. So we need to find the rate of change here. So the trickiest thing about time is that it's not base 10. We go 11, 12, and then we go back down to 1. So 9 a.m. we'll just count. So this would be 9, and we're at 23 feet deep. And so then 1 p.m. it would go 9 a.m., 10, 9, 10, 11, 12, and then 1. So that's really 1 p.m. would be 13, right? So that would be 13, 15. So change in y from 13 to go to 15 looks like we're going down 8, and over 9 to 13 is up 4. So that's down 2 feet? Yeah, down 2 feet per hour. We're going down. How many more hours will it take to completely drain the pool? So if you were at 15 feet at 2 feet per hour, so just 15 divided by 2, what is that, 7.5? So 7.5 hours. You are the pilot of an airliner flying at 30,000 feet. It's 1 p.m. Your scheduled arrival time into Chicago O'Hare is 3:05. Your optimum rate of descent is 1,000 feet per minute. What time will you start your descent? So we need to go from 30,000 feet and at 1:05. So how long, if we're going 1,000 feet per minute, right? 1,000 feet for every minute. How long will it take us to go 30,000 feet? Well, 1,000 goes into 30,000. What is that? 30 times. So that should take us 30 minutes. So if we want to land, and they should say landing, not arrival time, however. So your arrival time is 3:05, but we got to start 30 minutes before that. So what would 3:05 be? And then 30 minutes ahead of 3:05, that would be 2:35. So at 2:35. 11, job pays a base salary of $30,000. Each year an employee will earn an additional $2,000. The graph shows the employee's salary over 10 years. What would cause the graph to change in the following ways? The graph translates down Okay, well, if we translated the graph down, that would mean that we wouldn't start at 30,000. So we'd start at somewhere less. We'd start at somewhere less than 30,000. Okay, the graph translates up. That would mean, and these would be y values actually. So our y would be greater than 30,000. If we translate it up, say we started at 40,000 bucks instead, and we'd go up, every point would be up higher. The graph would rise less steeply from left to right. So if we rose less steeply, would mean we'd get less than $2,000. So we'd be, and that would be our M. Our slope would be less than $2,000 if we wanted to be less steep. And the graph would rise more steeply. That would mean that our slope would be, if we got more than $2,000 raise each time, so it would be more than 2,000. Which equation of a line perpendicular to this one? So we remember perpendicular lines have opposite reciprocals. So this slope is -2/5. So what would be the reciprocal of 2/5 would be -5/2, and the opposite of that would be +5/2. So we're looking for a slope of 5/2, and that looks like C. 13, which describes the relationship between the two lines, y equals -4x and y equals 1/4 x plus 5. So, well, -4, what's the reciprocal of -4 would be -1/4, and the opposite of -1/4 would be +1/4. So that's a +1/4, and we started here at -1/4. So those are opposite reciprocals, so the lines are perpendicular to each other. Write the equation of a line that satisfies the following conditions. Okay, so we want to be parallel to this line. So the parallel lines have the same slope and different y-intercepts. So y equals, as long as we have 3/5 x, let me write that differently, 3/5 times x, as long as we have a different y-intercept, it's fine. So plus 3, that would be a parallel line. Perpendicular, we need to find the opposite reciprocal. So 3/5, the reciprocal would be 5/3, and the opposite of that would be -5/3. And we could even use the same equations, or the same y-intercept. So y equals -5/3 x, and we could share that. C, intersects but not perpendicular. So that's going to be any equation that has a different slope. So y equals, and just change it. Instead of 3/5, we could be anything we wanted to. So how about 2/5 x plus 2? D, the y-intercepts are the same, so another equation with the same y-intercept. How about y equals, anything we wanted. 1/4 x plus 2. That has the same y-intercept at 2. The lines are the same. Well, that would be the same equation. Y equals 3/5 x plus 2. If we wanted to, never mind. Graph and label 4 lines, one with a positive, a negative, and an undefined slope. 0 and undefined. Okay, so positive slope, y equals 2x minus 3. Alright. Y-intercept is at -3, slope is 2. So up 2/1. And we graph our line. How about, now we want a negative slope. So y equals, how about -2x plus 3. Y-intercept is at 3, down 2/1, down 2/1, down 2/1. Up 2 left 1. A 0 slope, that would be y equals 5 or something like that. Right, so that would be, there's y equals 5. And then an undefined slope, that would be x equals, how about -6? That's a vertical line. 16, solve for the x and y intercepts. So the x-intercept is going to be 3x equals negative 18 divided by 3. X equals negative 6. The y-intercept is going to be 2y equals negative 18 divided by 2. Y equals negative 9. Zoom in here a little bit. 4x equals 24 divided by 4. X equals 6. Negative 6y equals 24 divided by negative 6. Y equals negative 4. 18. Negative 5x equals negative 21 divided by negative 5. X equals 21/5. I don't think we can simplify that. That's our x-intercept. Y-intercept, 3y equals negative 21 divided by 3. Y equals negative 7. Negative 2x equals 32 divided by negative 2. X equals negative 16. Negative 3y equals 32 divided by negative 3. Y equals, that's not going to simplify, negative 32 over 3. Says graph each linear equation. X-intercept at negative 3. Y-intercept at 5. And draw our line. Y-intercept is at 2. Slope is negative 1. Draw our line. Y-intercept is at 6. Slope is down 3, right 5. Down 3, right 5. Up 3, left 5. We can solve this doing finding the x and y intercepts, or we could solve it for y. So let's solve this for y. Let's add 3x. Add 3x. I'm going to rewrite this over here. So we're going to be left with 2y equals 3x minus 8, right? So then we'll divide by 2, and y equals 3/2 x minus 4. So y-intercept is minus 4. We're going to go up 3, right 2, up 3, right 2, up 3, right 2, and there's our line. 24, graph the linear inequality. So x, and notice there's no y, so that's going to be a vertical line. We've got the equal sign, so that's going to be, so we're looking at this, we're saying solid, and we're eating the number, so it's going to be less than, so we're going to shade on bottom, right? So solid bottom, so negative 2, that would be a solid line, negative 2, and we're shading the bottom less than that, so that's this side. And 2 points, well, how about this point, negative 4, 3. Negative 4, 3 looks like a good point, and any point over here works, and even including points on this line, right? This point on this line, because we've got a solid line, so that's, negative 2, negative 2. That would work as well. Our next one, y-intercept is negative 5. Before I get ahead of myself, dashed line, because we don't have the equal sign, and we're eating the y, so we're going to shade on top. So up 2 over 3, up 2 over 3, up 2 over 3, down 2, left 3, down 2, left 3, dashed line. And the top of this line, remember, imagine like rain falling down, so rain's going to fall on the top. So then 2 points again, we could say, oh, well, a point here. This is, what, 3, 2? That's on. Now, what about a point on the line? That would not work because it's a dashed line. But a point just above it would work. How about negative 3, negative 6? That works. This one is first solid line, because we have the equal symbol, and we're going to shade on top. Y-intercept is 6. Slope down 7, right 4, down 7, right 4, down 7, right 4, and solid line. And the top of this line would be over here. So 2 points, you know, we could have a point here at 3, 6. We could have another point here at 6, 1. There's an infinite amount of points that we could choose. Here, let's solve this for y. So we'll subtract 3x from both sides. I'm going to rewrite it over here. Negative 2y is greater than negative 3x plus 10. And then we'll divide by negative 2. When we divide by a negative, we need to remember to reverse the inequality symbol. So we got 3/2 x minus 5. What's our y-intercept? Negative 5. What's our slope? Up 3 over 2. Up 3 over 2. Up 3 over 2. Down 3. Left 2. Oops, 1, 2, 3. Skipped one. There. And so here, this was dashed, because we don't have the equal sign, and we're eating the rest of the equation, so we're going to shade on bottom. So we dashed line, and the bottom of this would be everything over here, and so we could pick out any 2 points. How about, what's that, 7, negative 8? 7, negative 8, that works. And how about 4, negative 1? 4, negative 1 works too. Any point over here will work. And that is the end